not gate.
Hello everyone, let's try to understand the main logic of gates. Let's start with the NOT gate. As you know, once we do not press the button, the LED is on, but once we press it, the LED turns off. Let's try to identify the reason. Let's say I do not press the button. Then the electric current coming from positive and trying to get to the negative side has only just one way, and it's the resistor 2. And as I haven't pressed the button, there's no current on the base of this transistor, so this transistor is not working. So the electric current coming from here cannot be collected by it, so there's just one option. It's going to the negative side through the LED, so LED is on. But once I press the button, then this transistor works because the electric current comes from the resistor 1 and it reaches the base of the transistor 1. So the electric current coming from resistor 2 would choose this part because in here there's LED, so it's the resistance. But why would they deal with the resistance while having just one way completely free? So they use this way rather than LED, so LED is off.
AND gate.
Now let's move on to the AND gate. As you know, there are 4 options for the electric current in AND gate. Either they will go through a resistor 2 or resistor 4 or through the push buttons. So if I do not press the buttons, the LED is off, but if I press either of the buttons, the LED is still off. But if I press both of the buttons at the same time, then the LED is then on. But why? Let's say I don't press any of the buttons. So these transistors are not working, so this way from here is blocked, and this ways are also blocked, actually, because as you can see the roads are not complete. So there are only 2 options. Either they will go through resistor 2, they will go through resistor 2 and resistor 4, but as this way is blocked, resistor 4 will have to direct the current towards transistor 1, and the resistor 2 has to, let's say, direct the current towards either 2 directions. Like, it has 2 options in this part, where either they will go through the LED or they will be collected by the transistor. But as the transistor works, of course they will choose this way because there's less resistance here, so the LED is not on. But if I press the upper button, then this rod is again not working, so this rod is not complete. I think we don't have to look at any other thing. The resistor 4 will first go through this way because it's way easier than energizing another let's say empty transistor. It will go through this way and see, oh my god, this rod is not complete, this rod is blocked, so this rod is completely unworking. But what happens? The resistor 4 will again go through transistor 1. As it's energized, resistor 2 again directs the current towards transistor 1, and again there's no need to go through the LED, so LED is still off. And if I press the second button but not the first one, then this rod from here is blocked and the same thing happens. But what if I press both of the buttons at the same time? Then there are 4 options. There are 4 ways to go through. Not options. If the road is complete, they have to go through this way. But after choosing the way, choosing the direction process is actually different. If I press this button, this transistor is working. If I press this button, then this transistor is also working. So this road is eventually complete. So of course, resistor 4 first tries to direct the current towards this part, and because this is, like, again, way easier than energizing an empty transistor, and as this rod is complete they can reach the negative side. But what happens to resistor 2? As this transistor is empty, because resistor 4 does not let the current go through this way, the resistor 2 has to direct the current across the LED, through the LED, so LED is on and the current is on the negative side. This is the main logic.
OR gate.
And now let's try to understand the main logic of OR gate. As you know, the main difference between the AND gate and the OR gate is the way the transistors are connected to each other. In OR gate, the transistors are sequentially connected, while in AND gate, the transistors are sequentially connected, but in OR gate, they are parallelly connected, as you can see. So, as you know, if I press either of the buttons or both of the buttons, the LED is on, otherwise it's off. Let's say I did not press any of the buttons, so but this transistor and this transistor is empty. These are empty. So the resistor 4 cannot direct the current through this way, so they have to energize transistor 1, and resistor 2 again has 2 options, and the current coming from resistor 2 will choose the transistor 1 because again there's less resistance here, so LED is off. If I press the upper button, then this transistor is not working, but this one works, so the current coming from here will be able to go through this way and reach the negative side. No need to go through this way. But the resistor 2 will try to lead the current towards transistor 1, but as this place is empty, as transistor is not working, it will have to go to lead the current towards the LED, and LED is on. If I press the button, then this transistor is not working, so resistor 4 cannot go through this way. But it can still go through this way because this button is pressed, so this transistor is working, and of course, this is way easier than energizing an empty transistor. So firstly, resistor 4 tries to lead the current towards transistor 3 rather than transistor 4, and sees that, oh my god, transistor 3 is working, so it just leads the current towards the negative side. And what happens to resistor 2 is, again, the same thing. As this part is empty, they will have to, like, the current has to go through the LED and reach the negative side, so LED is still on, again on. But what if I press most of the buttons? Then this will be available, or this will be available, like most of them is possible, are possible. And when it comes to resistor 2, as this way is again blocked because they chose transistor 3 rather than transistor 1, it will have to lead the current towards the LED, and LED is still on. Okay, thanks for watching. I hope you understood everything.